yesterday when you were with Coach Smith, you had an opportunity to talk about chemical and physical changes and indicators. Who can tell me some of those chemical indicators that y'all saw yesterday?
Flame.
Okay, flame was one. Very good. What's another one?
Odor.
Odor was one. Yes, sir. Very good. Light was one. Good job.
Color.
Color was one. Good. Can we remember any of our other ones? Okay, well that's not bad. We got 4, I think, out of 7. And so today what we're going to do is we're going to explore chemical indicators that tell us that a chemical reaction has happened. So everything we do in class today is going to be chemical reactions. Okay, so if you look at your paper, the first one says it's going to be lights out. So what do you think I'm going to do with a lab that's called lights out? Do you think I'm going to turn the lights out in the room?
Yes.
Okay. How am I going to do that? Okay, by flipping off the switch. Okay. What if I told you I'm going to take this candle and I'm going to blow out the candle without blowing on it and without pouring any liquid on it? What would you say? How could I do that?
Sorcery.
Okay, right here.
You may have like get like a cup or something and put it over it to like get out all the oxygen.
Okay, so I could put a cup over it. All right, but if I'm talking about chemical reactions, what might I do? Now that you've seen my materials, what might I do?
Mix them together.
Okay, so I'm going to mix these two things together and maybe have a chemical reaction that's going to be able to blow out this candle. Okay, very good. So I've got baking soda right here. And what I'm going to do is I'm going to mix it with vinegar. And what usually happens when I mix baking soda and vinegar? It bubbles up and I have an explosion kind of, right? Not like a huge explosion, but like just a little mini explosion, right? Okay, so what I'm going to do is I'm going to pour this in here and I want you to watch this slide. I almost put it out with my hand. Okay, so notice how it's fizzing. What I'm going to do is I'm going to take this and I'm going to blow out the candle. How was I able to do that? I'm going to do it one more time for you. It was the gas. Very good. So when I mix these two substances, what happened is that a gas was created, and that gas I'm able to tip over my cup, and all of that is coming out, and that gas is actually what's blowing out my candle, okay? And gas production was my indicator. So what I want you to do is I want you to draw a picture of what you saw. Okay, you're going to want to move in very close so you can see, okay? So I'm going to drop in some ammonia. Let's make sure I got enough. Yep, I got enough in there. All right, so I want you to look at it. What do you see at the very top?
Like fizz stuff?
Okay, it looks like fizz. Could it be, does it kind of look like maybe snowflakes at the top of that? Okay, so what you're seeing is a white solid. And this white solid, the white solid that is at the top of this, you can now see that it's dropping or falling down. Okay, that is a solid. Okay. And you see that solid falling out of there? Okay, and that solid was created when I mixed those two liquids. And those two liquids combined to make a solid. Now, when I look at this, is everything in there solid? No, but it did create a solid in there. And we call this, and I want you to write it on your paper, we call this a precipitant. And a precipitant is when I have two liquids that combine and make a solid, okay? So on your paper where it says to draw what you observed, I want you to draw a picture of this liquid with some flux in it, because those are basically flakes that are falling down. It kind of looks like it's snowing in there, like it's a snow globe. And then I want you to write this definition of what a precipitant is. Two liquids coming together to form a solid. Okay, so you can see I've got a pretty normal flame in there. And this is just water. I've been getting the sticks nice and wet so that they don't burn on us. And so when I put this in there, you can see it kind of changes the color a little, but that's the wood that's catching on fire, right? That's creating that color. But really not any vibrant color changes, right? Okay, so what I'm going to do is I have some salts here, some chlorides. And I call them salts because if you look at them, they look just like salt, right? They look just like salt. And in fact, I do have one that is regular table salt in here, okay? This particular one is called copper chloride. And I'm just going to put a little bit of the copper chloride on the end of this stick. And I want you to observe what happens when I put it in the flame. Okay. Alright, so what is making it turn that color? Because when I put my regular stick in there, did it do that? No, it didn't do that. So what is causing it to change colors? It's the chemical reaction. Very good. That's exactly what's causing it to change. So we're having a chemical reaction, and what is my indicator that I see here? Color change. Very good. Color change is the indicator that I see. I also could say that I see flame on this one. I know that what was made. Yes. So when the bag was inflating, what was causing the bag to actually inflate?
Oh my gosh.
What gas was being created? Very good. And I know that gas is there because the bag is actually getting bigger. The gas is flowing on it. Okay? Good job. That's fine. That's perfect. And then you're going to get, how much water does it say? 25 milliliters of water. Okay, and I've got a sink right there that you can use. Alright, so what do y'all predict is going to happen when we mix the water? Okay, it might fizz. Okay, so if it fizzes, what indicator? Okay, you're going to pour that in and you're going to stir. But if it fizzes, what indicator is present? What happens with the baking soda and the vinegar? A gas station. Very good. Okay, so what I want you to do is I want you to stir that up. And as you're stirring, I want you to hold the bottom of the cup. Is it really fizzing? No, so we know we don't have gas present. Hold on. Do y'all feel it? It is dissolving. Sine, you're almost done.
Yeah, we're done.
Okay, so let's make this into a real world. What might I use some chloride for? If when I mix it with the water solution, it turns real hot to cook. Okay, but would I want to cook with that? No. Okay. Okay, so let's think about a cold winter day. What might I use it for? A candle, or like to. Okay. Would this be good at melting?
Oh yeah, we already did that.
Okay, so what might I want to melt on a cold winter day? Snow. Snow or ice, so like the sidewalks. Very good. So we will use something like this and put on the sidewalks and melt the ice so that it makes it safe. Alright, so what did we notice when we put the grape juice in? What happened? Okay, it did bubble. What else did you notice? What did we notice? Okay, the smell of the ammonia lessened. Okay, so it changed. And it turned colors, right? So it changed like a darkish greenish black color. So what two indicators do we see here? Color and odor change. Very good. Good job, guys. Mix the citric acid, the baking soda, and the water. Okay. Okay. The bag expanded. So we actually had two things that told us that we were making a gas, right? So what was one thing that told me a gas was being made in here?
Wait, this one's open.
Yeah, so what told me that a gas was in here? Okay, the bag expanded, like it's still expanding, right? So I might take a little bit of this air out. Okay? It's okay. No, I just don't want it to explode. Okay? Okay. So the bag was expanding. That was one. What was the other indicator that I had a gas in here? What does it still do? Fizzing. So when I have bubbles, that's an indicator indicator that gas is present as well, right? Okay, and then you also mentioned that you have a temperature change. How did I know I had a temperature change? Yeah, you can feel it, it's really cold. When we started, it wasn't cold at all, right? Okay, so when we talk about temperature change, that's exactly what we're talking about. We have things that mix, and it causes the temperature change. So it's just me adding heat or cold to it. Because you didn't add cold to this, right? Nope, it mixed chemically and it caused a temperature change. Good job. What are some real world examples of chemical changes? Food spoiling, that's a very good example. What indicators do I see when food spoils? Color change, very good. The smell is definitely an indicator. Very good. Very good. So what I want y'all to do is you're going to log in to Nearpod and you're going to go to that brain machine. And I want you to play the games on physical and chemical changes. Good job, guys. And so you're going to think glass breaking, is that chemical or physical? Physical, so you're going to tap on the bucket. You're just going to tap. Yep. And it'll move the card there for you, okay? What did we get to see in this lab? Chemical changes, all right? So what were some of the indicators that we saw today? Color change was one.
Odor.
Gas production, odor, temperature change, okay? Precipitant, very good. That is a difficult one. Two liquids that form a solid, so very good. What else did we see?
Flame.
Production of gas. Did you have one left?
Flame.
Flame, very good. And with flame, then we also have light. So those are our 7 indicators. What is a good example of a chemical change?
Rust.
Okay, rust is a very good example of a chemical change. Someone give me another one.
Cake batter. Cake batter.
Okay, when you bake the cake, very good. That would be chemical.
Like when you boil water to make something.
Okay, so is boiling water, am I seeing any of these indicators? No. So boiling water would just be a physical change because I'm actually evaporating the water. All right, guys, y'all did very good. Keep this paper in your binder, and if you will put my iPads up, y'all can go.